state where each function is discontinuous and whether it is a point, jump, or infinite discontinuity. So beginning with number 16 here, discontinuities are going to be point, jump, infinite. Infinite are asymptotes. So if we look here, if we think about how we find asymptotes, the vertical asymptote is found by setting the denominator equal to 0. So that means that x equals -5. So it's going to be infinitely discontinuous. Sorry, so that's not showing. I'll just put ID for that. Infinitely discontinuous at x equals -5 because we have a vertical asymptote there. Okay. 17. This can factor. So I'm going to rewrite this as x plus 3, x minus 3. This is a difference of 2 squares. And then over x plus 3. So if we look here, we can cancel those two. So we have a whole. Anytime you can cancel factors in a polynomial, that is a whole. So we have a whole at -3. And then in order to find the point, we go back and plug it in. So we're going to say, here's my new function. After I take out that factor, it's only f of x equals x minus 3. So I'm going to plug in that value of -3 and see where this whole is at. So f of -3 equals -3 minus 3. So f of -3 is -6. So our whole is going to be at -3, -6. It's the type of discontinuity we're going to have there. Okay. So this one didn't print right, so we're going to skip that one. There is a greatest integer function. Actually, let me just rewrite it here. We can talk about it. So this is the one that looks like this. So this is going to be a jump. Greatest integer functions are always jumps. They're the ones that look like this. Something like that. So we're going to have a jump. This is just x equals 1, right? There's only one x. I'm sorry, not x equals 1, but there's one x here. So we're going to have jumps at every integer. Integer is just a whole number, right? So at every integer, at every 1, 1 plus 1 plus another 1 plus another 1 plus another 1, we're going to have another jump. Pretty simple and straightforward. All right, last one here. Number 19. So we have these two functions and we have these restrictions here. So I'm going to make a little sketch graph. So we have x plus 1, so that's up 1, and the slope is 1 over 1. So I'm going to go back 1 here, up 1 over 1, 1 over 1. Oops, I'm sorry. This is less than or equal to 1. So that's inclusive. Take that one away. Sorry about that. So that's going that way. And then we have this other one, x minus 3, going the other way, starting at x is greater than 1. So I'm going to go ahead and do like a shadow shade in here. It would technically start here for graphing, and then it's going to be up 1 over 1, up 1 over 1. So it's greater than, which means it's an open hole here, and it's going to be, my scale is a little off, I apologize. So it's going to look like that. So we can see that there's a jump, just like this greatest integer function. We have a jump at x equals 1, right? It's filled in because this circle is filled in and accounting for this one being open, but there's still a jump there, and we have to tell that that is the type of discontinuity. This is not a continuous function. There is a jump. So this will be our answer here. Jump at x equals 1.